see that 1 or 2% peak. And that's where the matching algorithm, it really is relying on you having multiple peaks and points of reference. And missing one of those doesn't negate a match at all. It just lowers the cosine score. So that's why we generally don't put the cosine score at like 0.99, you know, where it really has to match identically. It's 0.7, it's kind of a fuzzy search, as you can think. So that's essentially how we currently handle the concentration issue. And it is a challenging point. And just in general, if you're doing quantitative work, right?
Yeah. So regarding this this question, I work with compounds that have a very poor fragmentation pattern, and if I run them with a CID or HCD, I don't get the same fragments. But I have a standard that I want to upload on the library. Sorry. So I just want to know, should I upload both fragmentation, or should I, because then when I run my my environmental samples, they may match one of them, but you know, I don't know what.
Yeah, so I would suggest uploading both options, and that way. So in the match report that you get in the results menu, it does in fact tell you the type of collision used and the type of instrument collected on. So it'll tell you that it's a CID match, or it'll tell you it's an HCD match. And that way you can further evaluate whether or not you think that makes sense based on your data. But I would encourage definitely whatever data that you have, and you can even put it in the title. So you can say, like, you know, whatever the environmental chemical is, you can say environmental chemical, you know, CID at this energy level, or HCD at a different energy level. But the more data that we have, the more MS spectra under the different conditions, the different instruments, literally everything. It will address whether or not, like, how much variability is actually observed. So it can really get at like what the you know, we talk about how different instruments are not comparable, but we don't really have a lot of data to really support just how comparable or non-comparable they are. Whereas just adding all of this information to the database in the public domain, again, GNPS shares with MassBank, and we import from MassBank and Mona and things like that. A bunch of different databases. So if it's in our database, it's free to everyone else as well. And only doing that are we going to kind of get at these kind of questions. You know, how comparable is HCD and CID? It's a compound dependent basis, kind of like what you're getting at. Like, some of them will look more similar than others, and obviously different molecules fragment differently.
Okay, great, thank you.
That answers it. Yeah, not. I think you said it was a silly question. That is not a silly question at all. That's like a whole person's life of research right there.
And followed by that question, I have another question about this spectra. Do we, for example, if we have the standards, or do we need a clean before we upload our spectra? Of course, we have this noise from the instrument or from our background of the sample. Do we need to do the cleanup or calibration, or we just upload the data whether we see identification? But most of the case, of course, we don't have standards. Yeah, just one point is about the noise and background noise, and the other point about the calibration once we have the standard. Yeah.
So that's a great question. So first, the calibration, we definitely hope that the instrument is well calibrated. So that's something it's very difficult for us to fix. So Jeff, definitely like have your lock mask calibrated data. So the more accurate, the better. But with regards to actually removing noise, we actually don't recommend that particular procedure, specifically because when we do the matching, we try to do our best to remove noise there already, as well as this question about what is noise is kind of a fuzzy one. So what we just tend to recommend is you upload your full MZML or MZXML file for your whole LCMS analysis, or the whole file. That might include MS1 spectra in there as well, But then when you extract the MSMS, we take all that data with it, as well as we save that full file along with it from a provenance perspective. So if anybody comes along and matches your spectrum and has questions and wants to dig through the raw data and ask, is it a mixture spectrum, is it chimeric? They can look back at the original full data and make that determination. And so we generally don't, I mean, some people, you don't want to Photoshop your spectra before it's uploaded. In kind of my opinion, you can upload the actual raw data and it should be up to the matching algorithms to clean it up and filter out the noise. And then it should, then it's that responsibility rather than making a determination upfront on what's noise and what's not.
Yeah, I mean, there's no right, you know, this is kind of a subjective question, right? Like, what is a good spectrum, right? In terms of quality. You know, you could clean up your spectrum so that it looks pristine, where, you know, it has 3 peaks and you can perfectly ID every single one of those fragment ions. Sorry, there's screaming in the background. But you know, that's maybe doesn't match the real world scenario of like what your data is gonna look like. So I personally would suggest kind of what Ming is also suggesting, which is, you know, it should really be up to the algorithm to kind of look at your raw data, the actual MSMS, and handle that noise. And by having data like that, we can improve those actual algorithms and really tackle that question. Maybe not accurately, but at least consistently.
Yeah, good. Thank you. Great. Thank you very much.
Okay, so we probably want to just wrap it up. We wanted to say a few words on like look ahead and things like that. But first of all, thank you all for coming and sticking with it and being interactive. This makes, you know, everything more fun. And so definitely feel free to ask us questions regarding this as well as other GNPS things. And so one of the things we also wanted to ask you about is we have like way too many tools now in GNPS that are, it's kind of, anyway, people in Peter's lab don't even know a lot of them. So don't feel so bad if you're like, I don't know what's going on here. But we wanted your feedback on what would be most pressing for you all to learn in the next workshop or maybe a bigger workshop. We were thinking about doing something like this every week or every 2 weeks on different areas. Or we don't want like full day things because that's just like too much. But something like 2 hours, 3 hours per day spread out across a week or kind of even several weeks, hopefully will help you all. If you have any comments about which tools specifically you're interested in, there's things like MZMine, classic molecular networking, feature-based molecular networking, MSLDA, dereplicator, tons of little different things, MAST, Redo, a bunch of acronyms that don't really mean anything anymore. So there's a lot of things that we can talk about. And I know Alan and Morgan had alluded to them during the session. But some of the things that we are most excited about are things such as MAST, where you can take a single spectrum search across all public data, and as opposed to just simply reference libraries. But that kind of hook, it's like BLAST, but for mass spectrometry. And then there's also these ideas of with Redo about being able to say something about all public data. So a full LCMS run, is it from human? Is it from animals? Is it from food? Things like that. And annotating that and how to make that data really useful and how its tentacles have kind of spread out and how to use that interface. And for reanalysis, comparing your data to public data for co-analysis, things like that. There's a lot of possibility for us to share with you tools that we've developed. But we would love for your feedback. What problems stump you? What you think is important given your familiarity with our tools? As well as you are not just simply passive bystanders absorbing knowledge. We would love for you all to host sessions as well. If you're familiar with one part of the system, we would invite you to be part of this organization team. We're all remote anyway, so it doesn't matter if you're in San Diego or And so either it's hosting workshops, developing tutorials, helping with documentation, overall just inviting you to be a participant as well as a leader in this area. And overall, as the GNPS ethos is about sharing and community engagement, we wouldn't be here. We wouldn't be so lucky to have a useful resource and a popular resource without the community. So it's an open invitation. Even if you want to host something without our involvement, feel free. We don't have any propriety to that. So any thoughts, comments, suggestions, feedback, anything's helpful.
Maybe I start. I haven't used the GNS before. I heard it. Especially I read the paper of the MAST. I thought, oh, it is really wonderful. And today I learned another new thing about the redo. I think, oh, this is really cool. I definitely will try in the future. And we also use the GNPS, the spectral library, to import in our lab in-house library to combine them together to really use it. And yes, I would love to learn more about the redo. And this Alan, I think it's Alan said he just explained a little bit, and in our small breakout rooms, yeah. And but very, very important things, what your group or what you have done is really great to the community. It's really, really helpful and useful, because in the environmental chemistry field or metabolomics or the omics field, I think identification is really bottleneck. It's really, really a challenge for the whole community. It's a very, very, very helpful. Thank you very much. Yeah.
Well, thank you. Yeah, I agree. It's hard. We're not solving problem fully, but hopefully like we're moving the needle a little bit. So that's kind of a thing. So one quick thing I wanted to just give a shout out about. Alan tried to show it. There was like some hiccup on the server side, but sorry, I'm just a little excited about it. But if you're using GNPS and you upload libraries, but you want to publish a spectrum in a paper that looks nice, especially if you want it to match, we built a little thing with some collaboration with the Mass Bank group and a lot of people here, is we directly link out, but it's basically an interface that allows you to plot your spectrum as a vector that allows some customization hooked up to like Mass Bank, Metabolomics Workbench, MS to LDA, a bunch of different resources. As well as we do molecular networking, everything's kind of hooked up. It's a consistent way to draw stuff, and it'll be vectors so you can pull into Illustrator. So that's a thing. Like if you have spectral matches, you can generate mirror plots like this. We think it looks better than what we had, and of course it's vector, so it'll be infinite resolution. So that's a small thing. Just wanted to plug that. It's a kind of a big community thing. So
where can we find that?
So it's linked directly from any GNPS analysis or most of the analyses. It's like you can view the spectrum there kind of interactively, but there's also, it's called a Metabolomics USI. It'll link out to that and it'll draw exactly that spectrum that you were looking at. So hopefully it makes it a little simpler. Additionally, if you like to write code, it's an easy way to interact with that programmatically as a web API. So you can generate like all images for your entire data set in one for loop without having to like think about how to get the data, just kind of does it for you. So anyway, I know Alan likes to do that, but.
Yeah, I mean, just to kind of, I mean, not to, our own horn, but that tool has been immensely helpful with preparing manuscripts and like presentations, because the quality of the spectra that you get out is consistent, right? So it looks really good, as well as that USI. It is, I mean, I don't want to call it, okay, Minga's gonna yell at me for calling it permanent, but it is yeah, I know it's not permanent, but it is at least a consistent link, so that if you put that into the resolver online, it will produce the same plot. So I recently did it as like an SI. I just provided all those links aside with my annotations that I made. And that way anyone could go back and look at the same spectra and interpret it in the way that I did. So it's just a really nice like additional piece of information to add with your publications that just further adds to this ability to reanalyze, reprocess, and share the same data that everyone's looking at.
And one of the nice, well, first of all, if there's a reviewer is like, you should post all your spectra here, you can be like, screw you, here's all of them in like 1,000-page SI. Apart from being spiteful, one of the nice things, I'm sure, well, at least I've noticed this, it's like some people post images in the SI of spectra, but you can't actually go back to the peaks and actually look at the actual resolution. And so if you paste this in there, it's a semi-permanent link back. So then you can go, there's a link actually embedded in the SVG. So you'll go to the website and you can actually look at the exact data that went into generating the plots. So it's kind of like you can start zooming in and things like, as Alan said. So it just makes it a little nicer, and you don't have to just like zoom in on the PDF and trying to figure out what that exact mass is. But anyway, enough of talking about other things. Any other questions or comments?
Hey, this is Matt. Alan mentioned perhaps another workshop coming up. Did you guys plug that already? Is there on the horizon? I was thinking of maybe doing the office hours, but
yeah, definitely. So definitely the office hours are a standing thing that we want to host every Monday, just kind of for fielding any kind of question and kind of debugging. If you have, it's like, oh, this is a little weird on GNPS, what's going on? Because it's kind of grown bigger than we ever thought. It's kind of a monster now that, anyway, if you're in the software world, it's like, this is like the utter definition of feature creep. But anyway, so that's going to continue to happen, especially with people being at home. We want to organize other small workshops like this. We're thinking about a workshop with a few more lectures mixed in, but also maybe having somebody lead a similar workshop like that, that's very focused, perhaps on molecular networking, perhaps on a separate tool like Redo, where that's all we talk about. We'll kind of ancillary say, oh, and it links out to X, it links out to Y, but we won't spend much time on it. But it's just going to be kind of a core. We'll try to give you context on how it fits together in the ecosystem, but it'll be focused on one kind of tool. So we're trying to see your interests in what works. We're all kind of navigating this working from home thing, but that's what we're planning to do. We wanted to just use this as a starting point to see the community response and what you all found useful, and then parlay that knowledge into something coming in a week or two. So I had a great time. Hopefully you all did. So at the very minimum, we'll do another kind of small focused workshop like this. And then we'll see how that evolves.
Yeah, I just want to say thanks to everyone. Follow up on Matt's question. I am planning on holding a Redo workshop to go explicitly over some of those tools and analyses. So stay tuned. We'll announce that on Twitter, as well as yeah, I guess Twitter is the best place. We'll retweet it with GNPS's account. Yeah.
We'll tweet it, but not all people are on social media. What is the best medium for the people that are not on Twitter? Email? We'll
If you
spam
say it on
email
the
that you can sign up
GNPS
with.
homepage.
yeah,
Okay,
the
we can.
homepage.
Okay, we can put it on the homepage. We actually have a little Twitter thing on the homepage, so maybe anyway. We'll deploy something on the homepage as like a little banner ad.
So I've been asked this before, sort of announcements of workshop and creating a schedule of workshops, even if we're not involved, that they can add to that calendar. Having on the front of the GNPS website might be a really useful thing for us to do.
Yeah, exactly. I think that's a good idea. We actually, in our documentation, we have a little workshop section, but it's kind of hidden. You know, it's not like prominent. So perhaps we'll, first of all, add it there if you have a workshop coming up or we have a workshop coming up. But we'll also, let me try to figure out a maintainable scheme to get things updated on the GNPS homepage.
So I think there's somebody suggesting Facebook might be another place to announce. We don't have a GNPS Facebook page, unfortunately, but that may be something we need to think about. Yeah.
I don't even have a Facebook, and from what the kids tell me, it's not cool anymore. But
Well, maybe you should.
no,
get
I'm just kidding.
MySpace. Maybe you should get a MySpace account. Oh, somebody's suggesting a GNPS newsletter.
Oh boy.
Oh.
Let me think.
Or Instagram.
Yes.
Yes.
I do not have one of those. Okay, yeah, no, let's we will consider it. We can barely handle one social media, but we will think about the more effective communication. I guess you have to meet people where they are, right? So no, that's a good suggestion. So maybe there are, okay.
Well, Rachel Neve asked a question. For the metabolomic spectrum resolver tool, can I compare spectra from my samples to a standard not in the GNPS run?
Yeah, so you can compare it to reference libraries. So you can have, basically you can match up, the sources of data are from GNPS libraries, mass bank libraries, public data in massive metabolomics workbench or metabolites if you deposited the raw data there, or within GNPS analyses. So those are the multiple places you can source data from. And then what you can do for the mirror plots, or mirror, is you can have a mirror from any combination of those two. So you can have one spectrum from your GNPS analysis, another spectrum from another GNPS analysis, or from different libraries, different public data sets, somebody else's public data set. So the tricky bit is actually getting that identifier link. We generate those automatically within it, and we define how those are constructed on some documentation pages. Broadly, yes. It's a little bit, there's a little bit you have to like kind of feel through at the very beginning, but once you get a hang of how to get the identifier or construct it yourself, pretty straightforward.
Hello, Ming, where I can find it? I was searching it, but I didn't find it on the GNPS webpage.
Yes, so it's kind of okay. So let me link it to you here. It's already embedded in all of these analysis links, but it's like not kind of advertised as a standalone tool. But I just posted in the chat. And then so here are examples of different ways to resolve, but specifically we provide what they call like deep linking. So it'll be in whatever resource you're analyzing, like Mass Bank already links to it. If you're doing an analysis on GNPS and you do a library search, it automatically generates these links for you already. So that's where it's just, if you start seeing it showing up, you're like, oh, okay, that's a thing. But in order to source the data, it has to come from some web resource. So GNPS is one, but if it's like local, there's no server running on your local system. But anyway, something to think about. It's something we've been putting together for the last 6 months. It's all on my plate. I got to get the paper published, but hopefully it's helpful, and let us know about feedback.
Osama, I put in a link for feature-based molecular networking. We will, sorry, I misspelled your name accidentally.
Yes.
But we will have a workshop on feature-based molecular networking, but to get started, there's documentation right here.
Yes, I saw this documentation and I started, but I need hands-on. So I have some like data that I need to try to use it. So I try to use the flow chart, but at certain points I don't understand why I should. What's the difference between these different parameters? If I change this parameter or not, I get different results.
Okay.
Yeah.
So that might be, those are indeed kind of things that would be really good in sort of a hands-on workshop so that we can go into the details. But overall, using the documentation, was it pretty straightforward to begin using it or not really?
No, it was nice actually. Yeah, it was nice, and it's much helpful. Thank you for that.
Okay, great.
And it would be great if you can involve someone also from MZMind, because at certain stage, maybe sometimes I need help at the MZ Mine stage.
Yeah, so we've been communicating directly with people who do programming in MC Mine. In fact, I'm recruiting a postdoc that will start in August who is a MC Mine developer. We actually have several projects directly being developed together with the MC Mine developers. So they are involved, but they're not answering the forum yet. So if there are specific questions you have on that, I don't know. Does anybody know if there's an MC Mine forum?
There's a GitHub repository that you can ask about issues there.
Okay.
As a bare minimum. One of the things that we're trying to figure out on our side is running MZ Mine on GNPS with standard batch files, like standard parameters for different platforms. It's not going to be the best of everything with fully optimized, as you're saying, but it's a place to start. So let us know if you want to try that out. That's kind of a side thing. That's very beta. So
great, thank you.
But anyway, I think we'll wrap it up.
Yeah,
and
Ricardo highlighted that there's a really good tutorial by using the ADAP user manual. We should probably link that out from the GNPS site.
Yeah, let's add it. Let's add it to the documentation. Yeah, we'll just edit the GitHub. So yeah, that'll be great. That'll be great.
Yep. Thank you.
Thank you for sharing. Thank you.
Okay. Again, first of all, thank you to you all for coming, and thank you for the team on this side, Alan, Emily, and Morgan for all their hard work and putting everything together. We will see you around, and don't be a stranger.
Thank you so much.
Thank you so much.
Take care.
Have a good
Stay
day.
safe.
Thank you.
Take
Thank you
care.
very much.
Thank you.
Thanks, everyone. See you.
Thank you.